Whichever you want to do.
I really love questions, but I particularly love questions from kids. Okay, now we can define kids any way we want here, because this is just us. But I love to see how children's minds work and how they begin to grasp some of these concepts. So if any of the younger people have any questions, I would love to take those first. Or let them process for a little while, and maybe a question will pop up. So anybody at all who has a question. Okay, I can offer one. How does this process of cell division work, and how's it powered? All of the energy involved in this process has to be stored in the egg originally until there's implantation, so that as this division happens over and over and over and over again until there's implantation, the cell mass can be no greater than the original egg. It's just kind of a marvel. And so the cells get smaller and smaller and smaller and smaller and smaller in the process, but yet they become more and more and more differentiated. How do they do that? I don't know. Did you have a question, sir?
There's a youngster.
Works for me.
But my wife nudged me when you said, how do kids think? And I'm not a scientist, which will become obvious.
Oh, just grab the mic. It comes right out of the stand.
Which is also obvious. Is this on?
Yes.
Okay, a couple of questions.
Yes, sir.
Where in this process does DNA appear?
At the outset.
Okay.
DNA, the chromosomes that we're doing,
okay.
That's DNA.
Okay.
That's DNA. So that is the code for everything. It describes the whole process and the final human being. Okay? But the amount of data on the DNA is just staggering. Every time we think we've mapped the human genome and we understand the data of DNA and human chromosomes, we stub our toe on yet another magnitude of information, content there, and how that DNA and how the chromosomes talk to each other. You can count the number of genes, and you say, look, there's X number of genes on the human chromosomes. Isn't that dandy? Well, those genes talk to each other, though. And they do it in groups and in clusters, and it depends on which kind of cell. Oh, by the way, there's no junk DNA, because we've studied enough cells now. We figured out what that DNA does in all these other cells. So now we have yet another order of magnitude or two of information stored in that DNA. The minimum of our current understanding amount of data in there is about 1,000 Bible-sized books worth of information inscribed on your DNA. That may be off by several orders of magnitude by the time we look at the next, we peel the onion back and get to the next layer of data. It's unbelievable.
And the different things that are occurring,
yes, sir.
Is there a segregated or separate order in which things get done? Like we do this, then we do this? Or are this activity that you're talking about, is it all happening at the same time?
The answer is yes. No, that's a brilliant question. And the answer is yes. There's a set order to what happens with the nervous system. There's a set order that happens with the heart and the musculature and the intestine and all that. But all of that is happening simultaneously. How does it know? I don't know. And nobody does. We can see it and we can label it, but that doesn't mean we understand it. It's just a marvel. So yes, there's an order to any given system development, but there's so many systems developing at exactly the same time, it just becomes boggling in a hurry.
And it all goes together in the same way
Yes.
that it's supposed to.
Yes, sir.
We all have arms up here and legs down there.
And why we don't have a spleen hanging off of our nose is, can somebody tell me why we don't? Because it's in the program, you know, and that's why we don't have a spleen hanging off of our nose. Yes, ma'am.
This may be in the category of we just don't know also, but my understanding of cancer is it's just uncontrolled growth of cells. So can you explain what's the difference between a baby growing very fast and cancer growing very fast?
Brilliant question. And yes, much of the answer is we still don't know. However, with cancer cells, at the end of our chromosomes, each chromosome, there's a little, it's like that plastic stuff at the end of your shoelace. You know, it kind of ties off the chromosome. But it has a message on it too. And the message, it's called oh gosh, I'm going to use a technical term. It's called a telomere, okay? At the end of your chromosomes are these telomeres, and they keep your chromosomes from unwinding. But it also has a very important message at the end of the chromosome. It says stop, 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 stop. And it says it for a long time. Part of the aging process is the telomere gets shorter, and at some point your chromosomes begin to unwind. Apparently, part of the process of transforming a normal human cell into a wildly reproducing cancer cell is lost telomeres. And it doesn't have the stop mechanism. Stop doing that. You know, you're not supposed to be that. And so they just keep reproducing. And also, this also seems to be a similar deal on how we contract a viral infection. Virus has what amounts to normal human DNA and RNA, but it has no telomere at the end. It doesn't say stop, so we just keep reproducing it and reproducing it and replicating it, much like a computer. That's why they call it a virus. So that's the same kind of thing. So there's no end to the pursuit of information that we can gain here. Oh, you were just seeking a new seat. Go ahead.
I wondered in your process if you could discuss maybe when twins and triplets develop.
Sure.
And then maybe if you could topic of why dogs have litters.
Yes.
And things like that, perhaps.
Oh, dear. We will be here most of the night. Okay. Brief answer. Fraternal twins, identical twins. Fraternal twins are two fertilized eggs at the same time, two different ones, have totally different genetic makeup. Identical twins, one single fertilized egg, but it splits and becomes two developing embryos. We have twin granddaughters, and they were a rather unique circumstance in that they shared a common placenta and a common amniotic sac. This is an extremely dangerous pregnancy. They're called mono twins, and God blessed us with two healthy granddaughters because that's pretty rare in those circumstances. So a litter of puppies or kittens, there are multiple eggs and multiple implantations, so you can have as large a litter as the dog has uterus, and that can be lots. I'm not absolutely positive, but I think the record is about 22 puppies in a litter. I remember being wowed as a child to see 12 puppies in a litter, and it was just astounding to me. Your dog had a litter not too long ago. 10 and 9 survived. Yeah. So multiple eggs, multiple fertilization. Okay, here's where it gets weird. Litter of puppies can have multiple fathers. Enough said. Okay. Any other questions? Yes, sir.
Since I have to come up.
Close enough.
Is the process the same for all animals as the humans? And I'm not going in the direction of...
No, I know what you're saying. Basically, yes. In detail, no. The detail seems to differentiate about the time that that tube forms and separates that middle layer, and the middle layer closest to that tube starts forming muscle tissues, but it does it kind of in boxcar formation. These are, oh gosh, I'm about to use a technical term, somites. And that just means these are the different parts that form different parts, okay? Now, if you study those and you compare, as Ernst Haeckel didn't, but we won't go there, if you compare which one of those segments form arms, hands, ears, torso, various body parts, they're not the same. So there's no possible way from the embryonic development that we share a common ancestry with, say, dolphins,
Right.
or reptiles, because the forelimbs come from different parts, the hind limbs come from different parts.
So Haeckel's...
it was a lie to begin with,
is
but
completely
it's
unscientific.
Oh, it's beyond unscientific. It was a deliberate hoax.
It was a fraud. Yeah.
It was a fraud. But all of the further frauds or misunderstandings based on that totally unravel when you actually see what part of the embryo of a salamander develops its forelimbs versus what part of a fish develop the front fins.
Right.
You know, it's not the same.
But Haeckel's...
I know. It's still in textbooks.
It's still being taught. Right?
It's still in textbooks, yes. It's unbelievable. So, yeah, lying is education these days. So.
This should be an easy question to answer. Do you have a series or know of a series of videos that a person could purchase to illustrate what you've been saying?
You don't have to pay any money at all. I found dozens of videos on YouTube.
Cool.
Now, they won't... It gets funny because one of the better lecturers, he has a fairly heavy Australian accent, I believe, not Ken Ham. He kept saying, it's simple, you know, just follow this diagram, it's simple. And I thought, you're an idiot. It's not simple. It's not even close to being simple. So, yes, you can get a visual of what's going on, but it doesn't communicate the complexity of what's going on. Now, there are a few visuals. There's some animations of the process. There are some videos of stereo microscopes or phase contrast microscopes of embryonic development of, say, a trout. I studied a lot of trout and chick embryos back in embryology, and it's absolutely fascinating, but you lose the complexity of what's happening. You just see this change in form and shape, but what's really going on, you know, a couple layers down into it, is mind-boggling. How does it get there? It's just mind-boggling. So, do you have a question?
Yes. Can you chew on this question for a while?
Sure.
You said generally, all the time, as we know, we have a room full of healthy people here, that it just works.
Yes.
And troublingly, we know that there's some drugs out there like
Oh, yeah.
thalidomide that wreck the process.
Oh, yeah.
So if that affects the process. I'm wondering, does normal food affect the process at all? What is it about that and there's probably some other drugs that wreck the process too. Does all things you intake affect the process?
Good question. Brief answer, no. God designed this placenta, and the placenta is the roadblock for most of these environmental things. The things that cross the placenta are basically nourishment. Every now and again, there's a medication, there's an environmental influence that can cross the placental barrier either chemically or mechanically and interfere with the process. And it can be catastrophic, just like you're saying. When the process goes wrong, it usually goes wrong fatally, and we have a spontaneous abortion, stillbirth. Generally very early in the process, because all of this complexity, if you fiddle with it just a little bit, you don't get a live organism at all. So it's actually rare that you have something that fiddles with the process and yet you still get a living entity on the other end. So thalidomide messes with the development of limbs and such. And how it does that would be interesting to study so we understand more about the development of limbs.
So you don't get that.
Yeah, and maybe, just maybe, how to regrow a limb. So from something devastatingly tragic, we might learn something incredibly valuable. How valuable would it be for some of our returning veterans to be able to regrow a limb?
Yeah.
Possible. It's possible.
Like starfish.
Mm-hmm. Yeah. Bill, did you have a question?
Doc, I think you probably already answered this question, but if you had, then just give us more detail in the answer.
You may not want to know that much about it.
Well, I'm really fascinated with this idea of cell differentiation.
Yes.
Have they not been able to determine what's different about those two cells that start to differentiate from each other? They also migrate to a different position in the embryo.
Yes, sir.
So they're able to identify cells that are differentiating, and they still don't know what's different about them?
Precisely. You can see it happening. You can see these layers differentiating, splitting, and there's a lot of splitting, and then there's a lot of unifying, and then it resplits. Like the heart. The heart starts out as two tubes in the embryo. They fuse, become a beating heart, and then the heart separates again into separate chambers. How does it do that? We don't know. We can identify children that are born with a hole in the heart. It's an incomplete fusion of the chambers of the heart. We can see how the chambers do seal and how the little cells start here and they migrate there, and the little cells here and they migrate there, and they form a layer, and then another layer forms on this side of it. But there's a little flapper valve in there while the baby is still in the mom, and as soon as the baby is born, the pressure in the different sides of the heart changes, the little flapper valve closes and fuses most of the time. We don't know why it goes wrong. We don't know what stimulates those cells to even begin to differentiate and form something as simple as the chambers of the heart. You know, something as obvious.
How about genetic switches? Are they aware of certain genes that get turned on at that time that weren't turned on before?
That is a brilliant question. I haven't seen the data on that, but I'll bet that somebody asking that question would be able to pursue it and find out. that would give us yet another layer that we would have some understanding about. Does that mean that we know how it happens or why it happens? No, but we could observe a little bit more about it happening.
Yeah, genetically.
Yeah, down to the genetic switch. Yeah, that's genetics just keeps getting on more complicated all the time. If you were here when Gene Leitner was talking 2 months ago, didn't you feel smarter just being in the same room with that woman? Wow. I thought I knew a little bit about genetics. No. She had some concepts that I was just struggling with, and asked a question, and I think she helped me some, but wow, that's one brilliant woman. And to think that we have that level of intellect pursuing the study of genetics to the glory of God. Wow, that's amazing. Did you have another question, sir?
Yeah. Speaking of cells, could you talk a little bit about stem cells? We hear about that, and you're essentially talking about cells that essentially they're starting out all the same, but they are doing what stem cells do.
Yes.
They reproduce, and they become anything that God designs them to become.
Or the context that they're placed in. Yes, the initial cell replication, they're all stem cells.
Yeah.
Okay? Now, people want to use dead baby stem cells to cure diseases, and we find that stem cell therapy actually works better when you take stem cells from the host. So we all have stem cells in our skin, just under the skin, and it differentiates. We have stem cells in our bone marrow. We have stem cells quite a few places in the body. And when their switches go awry, they can become cancers of quite a few different varieties, because they differentiate into sort of kind of muscle cells, or sort of kind of nerve cells, or brain cells, or kidney cells, or whatever, but they go awry on some of these switches. So yes, stem cells, true stem cells have the ability to become anything. I've been reading some studies I think are just wonderful on how they can treat childhood diabetes, which is vicious, and they can take stem cells from that child and implant it in the pancreas. Those stem cells in the pancreas say, I'll become the kinds of cells that produce insulin. And a fairly recent study in Brazil, they did it on 13 children, all but one of them were able to get off of insulin altogether. So stem cell research is wonderful, and especially that we understand that that's the process. It's designed into those cells to be able to do that. But it all seems to be context. If you took those same stem cells and put it over in a damaged heart, what would they become? Heart muscle. If you put it in, potentially, if you put it in a damaged spine, what would it become? New spinal nerves. We're not quite there yet. Not quite there yet, but I think there's some really encouraging data on that. So, yeah, stem cells, and yes, you're right. The definition is, at the beginning, they're all stem cells.
Yeah. Okay. Thanks.
You bet.
Well, while we're on the subject of stem cells, I think you started to talk about adult stem cells versus embryonic stem cells, but I never quite heard an answer on that. And
I didn't
was wondering
close
if
the
you
loop.
could differentiate between the two. And I also have another comment, which I can probably, which is unrelated, I can get after he gets done.
In theory, stem cells are stem cells are stem cells, but that's not quite true. Embryonic stem cells, are a little unruly, kind of like small children. And they need parameters, kind of like small children. And if you take embryonic stem cells and they don't have enough context or parameters, they become tumors, they become cancers, they become all kinds of things. Adult stem cells, especially if they're your genetics, they already have some parameters built in because they're in your bone marrow and under your skin and such. Then we take those stem cells and put them in the right context. They already have these parameters around them. Let's just call it discipline, for lack of a better word. Then they're more likely to develop into healthy tissue in which you've implanted it. And I think we've just scratched the surface on that. Did you have another?
Well, I had another thing. It was a comment. It was unrelated, but I was just curious that group you were talking about that had the diabetes, the childhood diabetes. Were they treated with adult stem cells? Or
their own stem cells.
With their own? Okay.
Yes, their own. They were it's called autogenous stem cells. Oh, there was another term. I'm so sorry.
We're understanding less and less.
Yeah, I'm really trying not to.
I find this really fascinating to understand the complexity on how the cells can change and how it can be very minor changes that can end up doing something. You can still come out being healthy. It might be a little hard to see this, but I'm not symmetrical. My body's not symmetrical. Most people aren't symmetrical, but the closest example I have, left and right hand.
Mm-hmm.
One hand is bigger than the other. Normal size, normal fit for my body. The other one is kind of deformed and kind of quirky. How do we take and see, with what we're able to see, in the cell division, it's kind of hard to see it when that's going on, because if you're looking at it, you almost destroy something when you're doing that.
Yes, the act of observing it destroys it, yeah.
Yeah, the act of observing destroys it. But you have something that just a little itty-bitty thing came back with a hand is a little bit shorter. And it's, to me, that makes it pretty amazing. It means there's so much more in there. Could it be that just something was just a little bit different? Just a little bit different placement? But can we even see that difference in sequence? Yeah.
We can guess.
We can guess, okay.
It could be mechanical. Like a traumatic injury, a blow or a bump that your mother experienced. It could be environmental. It could be something that she ate. It could be something that crossed the placental barrier. There's so many different influences. The good news is, relatively, it's incredibly minor, and you turned out to be a human being with not necessarily mirror image symmetry. None of us are totally symmetrical in any case, but it's just a little bit more obvious. Why? We really don't know. It's an interesting question, an interesting study, and it might help us help pregnant moms deliver healthy babies if we knew a little bit more about it. But right now we really don't.
Okay, then I kind of follow up a little bit. I'm a lot older. This hasn't changed very much.
Yeah.
It did what it did. It grew. As I got older, it got bigger. As I got older, it got bigger, and then I reached a certain age, and it doesn't change anymore.
Mm-hmm.
And now I'm starting to shrink and get smaller and so forth. But as far as I can tell, from the time I remember, this hand proportionality has always stayed the same.
Mm-hmm.
I had surgery to remove webs, but the shape, the size changed, but the shape didn't. And how many times have these cells been replaced?
Quite a few.
Quite a few times, and they continue to replace them to provide pretty much an identical hand through 60, 50, 60, however many years. It hasn't changed too much.
Once our limbs, in particular, establish the context of being that limb, it's going to be that limb. You know, yes, the cells renew and replenish, but the context describes exactly what it's going to look like: its shape, its length, musculature, innervation, things of that nature.
So this cell on this finger is always going to be the cell on this finger, somehow location-wise.
Yes,
How do
sir.
we describe that location? I don't know. How do we find that information coding in that cell to know? How's that different than the nose? We don't know yet.
We don't know. That's a point well made.
If only we could figure out in terms of the density of the hair.
Well, I'm pretty dense. I don't know about my hair, but
Getting pretty sparse.
your brain is just growing right up through your hair is all. So.
I wonder if you have given any thought to if there might be where the line falls between God's supernatural involvement and more of this deistic idea that He's spun us out, you know, when Adam and Eve were created and we're just the outcome of
Sure.
the combinations, or because our consciousness, especially, that each of us would have the unique consciousness so that to separate us from animals. And we certainly know His formation in the womb was superintended by the Holy Spirit. And we, of course, know that Scripture says we were knit together in our mother's womb by the Lord. So I don't know what thought you've given to it when you say, I don't know how that happened. Well, at what line do we say
we can
it's not
see
spun
the
out?
evidence
Yeah.
for exactly what you're talking about, though. That band of tissue that becomes the baton, that is hands-on. You know, it can't just somehow appear. You know, the maestro says those cells are going to become that band of tissue. Now I'm going to pick up the baton and I'm going to direct the symphony with it. The differentiation of the chromosomes in the dividing cell, where those little fishing reels on either side of the nucleus send out their little fishing lines and tell that mass of knotted yarn is kind of what it looks like under the microscope, and it organizes it, and all of a sudden you have all these nice orderly X-shaped chromosomes that line up precisely in the middle of the nucleus, and then these fishing lines go boop, and they separate them into halves, and each half immediately replicates the other half, so that you have identical chromosomal makeup in the daughter cells. Those fishing lines, how do they do that? Does that just happen? Is that just part of the mysterious program? I see hands-on. I really see hands-on. The whole process pretty much has to be hands-on. You know, to form this incredibly complex electromechanical, biochemical machine that can think and laugh and love and appreciate art and beauty and communicate and commune with our Maker. That can't just happen. It can't just happen. And it can't be thrown out to just kind of keep doing that. What would happen if you designed a computer to design a computer to design a computer to design a computer to design a computer 15 trillion times? What would you get at the 15th trillionth computer?
Really good one if you're right.
If you're hands-on. But if you just design the first computer and you walk away, what would you get?
A highly evolved computer.
Entropy happens. Ask my grandson.
Fascinating, Dr. Hudson. The more I think about it, I kind of want to keep going backwards, see if it makes sense to you that if I muse that at some point that baton is directed by God, then God has to walk away at some point and let the machine take over itself.
No, he doesn't.
Otherwise, I feel like when defects come in, you would be saying God purposely caused that. Hang on a second. Let me go back. So I tend to think that even that initial process, while we don't understand it, could be self-directed with the genetic makeup of both the sperm and the egg, that when they come together, though we can't understand it, all of the mechanisms are there, be they at the not just chemical messages, but could be, other forces involved in there. But it's not necessarily of God. It is designed by Him, created by Him. But that's the beauty of how you can bring those two things together. They have to be of the right like kind, but they will always produce people. They won't produce rabbits. They won't produce whatever. So he's set that from the very beginning. We have no clue how and why that does that. But so yeah, I wonder at what point is either God actively involved from the very beginning, but then walk away and let it say, okay, I ignited the spark, and it's all going fine, so I'm going to step out of that. Or no, from the very beginning, I designed these two things that when you bring them together, voila, watch what happens on the physical basis. But what blows my mind is what the lady back there spoke with too, is when does the spirit and soul get in? What does it inhabit? How does it stay there? Why is it? Why? That whole thing just baffles me. Where does it fit in the very beginning when it's just two cells? So, fascinating. So
you've asked about 8 great questions.
I know, sorry.
I can answer the why question right off the bat. Same answer that God gave Job, because I'm God.
Right.
Okay.
Yeah.
Now, the entire universe, or the tiniest subatomic particle, we can measure what's not there, holding them together. We can measure the actual force that's absent, so that there must be a force that's holding them together that is undetectable. No, it's not dark matter. Okay? So, is God hands-on on the universe and the smallest subatomic particle all the time, from moment to moment? We have absolute evidence that that is true. Okay? If He doesn't walk away from the universe that He created at the outset and the smallest subatomic particle that He created at the outset, why would He walk away from you, from creating you, which was the whole point of creation to begin with? What keeps your heart beating? What keeps your lungs pumping? What keeps your brain functioning? Is it just some program that got set into motion some time ago? Partly yes.
It glorifies Him.
Partly yes.
It doesn't take away.
But I just don't believe that God has His hands on everything going on in the universe, from the micro to the macro, literally from instant to instant. But He's not doing the same with us.
That'll be the mystery we won't know this side of heaven.
Yeah, and it's a fascinating intellectual pursuit, but I'm pretty sure we have enough significant evidence that left to itself, these genetic processes would degenerate very quickly. Very, very quickly. Yes, sir?
I think the scripture speaks of that. Just as you don't know how the baby is formed in the womb, you don't know the work that God is doing in the universe. So He's involved in the baby forming in the womb just as much in the universe. So I think that speaks exactly to what you're doing.
Yes. Did everybody hear that? The scripture addresses it, and just as we don't know how God is forming a baby, we don't know exactly how God created the rest of the universe, and so that we know that God is hands-on in both processes, and both of them speak to His power and involvement. Direct involvement, hands-on. God doesn't just walk away. Now, some of the confusion comes into the fact that we live in a fallen world, in a fallen system. So, could God fix that? Yes, but being holy and just, He would have to destroy it. It would have to go away. So out of mercy, he maintains this fallen system in which there are defects and cruelty and suffering and death and disease and all those kinds of things. But God is not willing that any should perish. So he allows this fallen system to continue, but he sustains it. That's also addressed there in 2 Peter, that God upholds this universe, this cosmos, from moment to moment for the pending judgment. And us. Yes, sir.
I was thinking about what you said about when human life starts. How can we do research in this area ethically? And how much of what we know already came from things we would find unethical? Were embryos killed to get the knowledge we have today?
Yes, they study aborted embryos. Could we have gotten the same knowledge without dead babies? Yes. We don't have to kill a baby to understand these processes. We can study them quite well in non-human life, and we can study them quite well at a remove with sonograms, with greater and greater accuracy of our microscopic studies. Sometimes they have to do a partial birth surgery for an infant, that has a malformation of their heart or something of that nature. So the baby is partially born through a cesarean. The surgery's done, then they close the womb back up and put the baby back. So does the baby have to die for us to learn that? No. So there's lots and lots of ways that we can, yes, we have gained in our knowledge from dead babies. We don't have to kill them to get dead babies. We have stillbirths and things like that we can study as well. So, but medical ethics and bioethics, you always want to default to the least possible harm. Okay? And the least possible harm is, once that's a fertilized egg, that's a person. And anything short of that, you're doing something pretty risky. You're pushing it. I don't want to be that guy. Any more questions? Yes, sir. I love these questions. You guys think. It's wonderful.
Some of these questions come from personal experience or family members. Mm-hmm. One of our family members had a baby boy who was born with hydroencephaly. Mm-hmm. Virtually no brain. He was deaf, very large head. His eyes would go back and forth like that. But mm-hmm. they waited to see if God would do something. Mm-hmm. They knew early on in the pregnancy that the baby was hydroencephalous, and they were encouraged to keep, they're Christians, they were encouraged to keep the baby, but they just could not live and try to care for something that could not live on its own. Mm-hmm. And so they had to let him go. It was a very sad story, about 2 years ago. The good news is she's pregnant, another baby, it's a boy, as was the first one, and everything's fine. Mm-hmm. But what the question would be, what causes this sort of malformation to the best of your knowledge?
That tube that I was talking about that forms the central nervous system, it's open on both ends.
Right.
And the forend that becomes the brain closes at about day 26 or 27. And if it does not fully close, that's where anencephaly and hydrocephaly mm-hmm. come from. The hind end, lower body end, when that doesn't fully close, we get spina bifida and sometimes hydrocephaly along with that. So it's a both and. So anything that interferes with that closure at the proper time, we get those kinds of birth defects. Is that a human being? Yes, that's a human being. Now, bioethics and medical ethics, I don't believe we should ever do anything active to terminate life. That's murder. But sometimes we need to decide to not do something active to deliberately prolong life where there isn't self-sustaining life. So we're playing God on either end.
Exactly.
And sometimes we have to take our hands off and turn it over to God. But we should never, ever, ever do anything active to terminate life. That would be murder.
That was the approach they took.
Yeah, yeah. We have a handicapped daughter, and there's a lot of soul searching in that, and she's turned into one of the major blessings in our life. So,
kind of on that same subject, gene splicing. Now, if they can properly identify the problem area, oftentimes there are several genetic pieces that contribute to a problem. But I guess my concern would be that the gene splicing would have effects beyond what is intended. What is your opinion?
Well, that's a brilliant point, and thank God we have people like Dr. Jean Leitner studying those things on our behalf. She enlightened me rather a lot on how genomes are selected during this division process and even the formation of the egg and the sperm. There's a positive selection going on there. We knew for some time that there's a spell checker going on in our genetic systems, where the spell checker goes along our chromosome and will zip out mistakes and put in the correct information. But apparently, according to Dr. Leitner, it can zip out information and put in information that's going to be needed. How do it know? I have no idea. Now, is it a greater amount of information than was there to begin with? No. It's merely different information, and sometimes information is lost in that process, which I would predict. Okay, now, when it comes to gene splicing or gene correction, if we have good understanding of that spell checking process and the process of zipping out a defective or environmentally incorrect genome and can splice in the correct information, preferably from studying a family member, and not just say, well, let's go out and get some genetic information from corn and pluck it in there. Then I think, yes, we can have genetic therapies to correct genetic problems. But bioethics, without God in the equation, directing the research and the treatment and such, we can get in trouble really, really fast. So yes, I think your concern is legitimate, because God seems to be taken out of the equation way more often than not. Now, He still is in charge of the genetic information, but we can play with it, like we can play with dynamite, and we can use dynamite correctly or incorrectly. So, any other questions? Oh, we got lots. Oh, I love this.
Could you go into a little bit more specific history of how you actually came to know the Lord?
Sure. It's just a little bit more detail of the same thing. I was raised in a Christian home, born in Oklahoma, which is kind of that sharp, pointy thing on the buckle of the Bible belt, really holds it all together. And we were Southern Methodist. Most of you have no clue what Southern Methodist is, but there's not a dime's worth of difference between Southern Methodist and Southern Baptist, except Southern Methodist can dance, and there's slightly less water involved in the transaction. Okay? But there's a whole lot of fire and brimstone going on. Okay? So I never heard the message of salvation. I heard a lot about sin. I heard a lot about hell. I heard a lot about Jesus, but there was no connect going on there. So, you know, I was afraid of going to hell. We moved to Colorado when I was about 12, and there were no Southern Methodists here. Go figure. And so we went to a Methodist church that was incredibly liberal for the time, and nothing much there. You know, they basically shoved me out the door. You know, at 12. If that building is still standing, I could walk you to the children's wing, to the correct room, and within a couple feet I could show you where my faith died in 1962. And it took quite a while until 1982 till God reached me through my own children. So I was a happy atheist through high school, through my undergrad education, dental education. In that process, I've calculated I took the equivalent of 26 semesters of biological sciences, and in every one of them, evolution is at least an assumption, if not the subject of study. So I was very thoroughly indoctrinated and bought it all because I kind of wanted to, because I wanted to be in charge of my own life, and I'm so darn smart I can do this on my own, etc., until I got children. Married. My wife is a Catho-Baptarian. And, you know, she knew she believed in the Lord. And early in our marriage, she started going to a women's Bible study. And I really kind of wanted to ridicule her for that, but I really honestly respected her for you know, doing what she believed in. So she was a kind of a silent witness to me. And then God gave me children, and I was holding a baby boy in my arms and thought, if I love this baby this much, how much must God love me? And I thought, I can't take that and stay an atheist. And God said, yeah, that's right. So God witnessed to me through my own children and taught me many lessons through my own children. Obviously, I needed a lot of them because we ended up with 28 kids going through our house with foster kids and such, and unbelievably blessed. That was not my plan, by the way. You know, it was somebody else's plan, but it's amazing how much you can learn raising children. And now I'm blessed with so many grandkids, I'm almost at the extent of fingers and toes, being able to count them. So the good news is that upon becoming a Christian, God gave me the gift of faith. Kind of funny when you think about it. And I knew that the Bible had to be true. It had to be true or the whole thing fell apart. I didn't know how it was true or why it was. I just knew it had to be true. So I started on my own journey of discovery to figure out, you know, how does the real world fit into Bible context, not the other way around. Okay? So if the Bible's true, then there had to have been a real garden with a real man and a real woman, a real fall. You know, it had to have been in a very good state, and then the consequence of the fall had to lead to the condition of the of creation that we see now. And so, fortunately, the seminary library was open to public access. I'm not sure it still is. And so I checked out a bunch of books, and my criteria on the divide seemed to have been over the flood. So I started just studying the evidence for the flood. Come to find out that the flood has never been disproven, it's merely been disbelieved. That's silliness, you know. And when you start looking at the evidence that supports the flood, then virtually all of the evidence that supports evolution is out the window. And I studied all that evidence, you know. But it's what I thought was a giant mountain of evidence for evolution turned out to be a hollow bubble. There's nothing in there. There's nothing. All you had to do is go poke in one place and the whole thing went and was gone. So amazing, absolutely amazing. And yet we have a whole culture built on that fallacy, that lie. Amazing, amazing. It's amazing we have a culture at all. Yes, sir.
Could you speak a little bit to cloning, the subject of cloning?
Maybe.
Please.
Cloning gets into that realm of bioethics where you're replicating someone's exact genome, exact genetic description. For what purpose? For what purpose would we be doing that? We could be doing it for vanity. Somebody wants a child that's exactly like them brought into the world. They've been shown in clones of higher animals, sheep and whatnot, that they age out rapidly. The new entity born that way has an inherited age to its genome, and I think it's the telomeres that begin to shorten as we age. Dr. Elizabeth Blackledge, Britain, won a Nobel Prize from studying telomeres, and according to her data, she can predict your exact age of death by studying the length of your telomeres. So in a clone, there's an inherited age. The telomeres, I don't know this for a fact, but I would predict it, would have inherited the age of the donor. So would age out much more quickly. I don't think that's ethical. That does not strike me as ethical. Okay, brilliant question. Have I exhausted everybody?
Yeah, well, usually when the speaker is done with his speech, we have a question and answer period. So, no, I'm just kidding. Okay, let me start over. Usually we try to kind of start wrapping things up around 8:30. However, if there are more questions, and this has been a great run of questions. What? Okay. We'll get to that in a minute. So, is everybody okay with us hanging out a little bit longer before we go have refreshments and ask questions?
Yes, I am.
All right. So why don't we, are you okay? Are you exhausted?
No, once I'm on a roll.
Okay. Then
it's hard to get me to stop.
Let's revisit this in about 15 minutes. How about that? All right. Next question.
I know a person who had cancer diagnosed in 1994, and they started measuring cancerogenic embryonic antigens, or CEAs they called them, or something close to those words. And hence, the more you had of those, theoretically, the more cancer you had in your body. And the embryonic word came out. Can you explain a little bit what that is? And were they always in your body and
yes,
and developed? Okay.
With very rare exception, every vertebrate, and specifically every mammal, has oncogenes. These are the genes that can go wild and form cancers. Except for buffalo. What? Buffalo never get cancer. Okay. Not too sure what that's all about. But yes, to the point. The wild cells, the wild stem cells, and that's what they're talking about with embryonic, are in your body at all times, in your circulation at all times. Now, as part of what our immune system does is it finds those, and they are you. They're your genes. These are your cells, but our immune system is smart enough to find the ones that don't belong. And generally it's white blood cells that surround them and zap them. Sometimes it's the white blood cells that go wrong. You know, that's leukemia. But yes, God has designed our bodies to be self-correcting for the most part. Sometimes, whether it's environment, bad choices on medications, drugs, alcohol, whatever, we manage to overwhelm our designed-in defense mechanisms. And sometimes I think we succeed in giving ourselves cancer. Sometimes it may even be attitude. Strange. That is a very long pursuit all by itself. But yes, brief answer. Everybody has potential cancer cells in their body at all times. Yeah. Is that everybody else's understanding? Any disagreement on that? Yes, sir.
So it seems like with the complexity of the cells and the interaction and communication with the cells, and it's kind of hard to see communication in action.
There you go. That's where I was going.
You can see visuals. If you see something visual, you can measure it. If you hear something, you can measure it. There's a lot of different things that we can't come together with. But what's amazing is each cell comes up with a place that it says it's orientated in a particular spot. Your bone, when it heals, when you break a bone, you can take and overlap the bones, it will eventually heal, and then eventually the body will take away the extra material where it overlaps, and it makes it back into more or less the shape that it's supposed to be in.
Yeah, remodel it, yes.
It can conform the shape of the knee back into the way it's supposed to be so that you can walk and the joint moves along without pain. That happened to me. I broke my leg and I sheared a piece off and they put it back, and then he says, I put all the pieces on the other side back. But he looked at me and he said, those pieces were so small and everything else, I just kind of put them back into place. And the miracle was, what the body ended up doing is it said, oh, I'm going to reform this surface that the surgeon left as being very rough. I'm going to reform that surface to make a very smooth joint that moves back and forth inside the curves exactly where they need to be. We still don't know how it does that.
Brilliant observation. Yes, we can see the effect, and we know there's some form of communication telling that bone, go ahead and heal. When you're done healing, let's remodel it, let's resculpt it into its original form. Where does the sculpting data come from? Where does that communication come from? We can see the effect of communication. Where does it come from? Where is it? I don't know. But that's part of the awe of it. Yes, you can observe what's going on. You can observe these cells differentiating, moving around, coming from all kinds of different places, and all of a sudden they get together, and somehow something communicated to them to do that. Was it the maestro's baton? At least partially, but we don't know where all this communication is coming from. But it happens, and it happens essentially perfectly, way more often than it gets it wrong. Way, way more often. That's good communication, which means good design, which means brilliant designer. You know, it's inescapable. Inescapable. Yes, sir? Oh. One more, just one more. Well, I love questions.
Follow up on that question. My son was involved in a car accident 6.5 months ago. Shattered his right leg, both bones broken. He's now walking. He's doing some work. But there's a piece of bone missing on the outside of the rod. They had to put a rod in through the kneecap. They're recommending, and it'll probably be done in early May, to do a bone graft. They're going to take bone from the side of his femur and just shavings and implant it into the leg. So you're telling me that God's going to take those shavings and cause that to grow together with a bone transplant or implant and reshape that bone just like it's supposed to be?
Probably.
Probably. What about the fibula, the small bone on the outside? That was broken in several pieces and they left it there. They had to take one piece out of the tibia because it was so shattered and a lot of mess in there, and they had to clean it up.
Right. When the bone is shattered, and basically all you have is dust and particles. If you can reshape those in a proper environment where the body doesn't try to reject them, and that's the real issue. You know, does it look at it as leg bone, or does it look at it as foreign object? And if it's a foreign object, the healing is very poor. Well, we've learned a lot about how to do those surgeries and put a context around them where the body says, okay, well, they're not foreign objects, so I'm going to treat them like bone. A lot of this original research was done on soldiers wounded severely in Vietnam, and they got them off the battlefields and into surgery on the ships just offshore in a matter of minutes very often. And these guys would have a good portion of their faces blown off. I mean, no jaw. I mean, it's just not there. Now what do you do? Well, brilliant surgeons, they did a lot of research, and they would take hip bone, they would take rib, and you have to put a context around it so that it filters out the white blood cells that would attack it and treat it like a foreign object, and they could sculpt an entire jaw, which then the body would say, oh, that's jaw, and it would reshape it further into being jaw. Amazing, amazing, amazing.
Well, what is this context you're talking about?
Millipore osmotic membranes that they would put around the, it's like an artificial periosteal layer. Periosteum is the part that goes over the bone that tells the bone how to heal.
Okay.
So it becomes kind of an artificial layer like that, so the body doesn't therefore treat it like a foreign object. And wow.
Any good doctor would know that.
Brilliant surgeons do.
Yes.
My son was in a bad car accident in '01. How he wasn't killed, we really don't know. But he had a crushed pelvis. And that was quite a process of healing because the pelvis flexed, even with pins in it, which eventually worked their way out. That was painful, and an ongoing lesson. But yes, his pelvis has knit, but I think for the rest of his life he'll probably be reminded during bad weather that he once had a broken pelvis. But yeah, bones heal, and you look at it and think, how does it do that? Well, there are little cells in there called osteoblasts that form new bone. They can form new bone, but they also need the context to do that.
Okay.
That's why there was a big lump there, and then it reshaped. There are also other cells called osteoclasts. Oh, I'm using terms again. They eat the excess bone. How do they know where to stop?
I basically had it described to me that they wanted me to start walking right away.
Yes.
The thing that happened with my broken leg was that the mold on the top stayed undamaged. Everything that was there was not damaged. So when I started to heal, and they had me start working it by moving and doing that stuff, I see it as the context of the cells all the way around it began to figure out where they needed to be. And one article that I read, it kind of described, as you work the body, as you stress the body, you stress the bone. The bone then reforms to adjust to that stress. Somehow it does that.
Work stimulation.
Work stimulation.
Mm-hmm.
And when you look at the bone and you see you have this smooth outside surface, and then when you look at the inside stuff, it's like netted honeycomb of
Mm-hmm.
things. The bone is not the same all the way through the bone.
No.
There's different layers all the way around, and if you have that all in context, then it seems to fit together, and if it's not damaged and you work it, it'll heal. That, to me, is a miracle.
Yeah, yeah.
How that works, and we have no concept.
There's communication there. We can see the evidence of it.
I have a couple of questions.
I hope so.
Which I'll give first, but I also have a comment, which is probably born of naivety, but I'd still like to make the comment because it is in the context of what we're discussing, this whole issue of body parts reforming and all that sort of thing. But the first question I have is kind of stepping back a little bit. In Genesis 1, it talks about, I think in this case it's talking about plants. It says the seed is in itself.
Yeah.
And then I've heard other people commenting on similar things, like the concept that the human being is one person.
Mm-hmm.
I mean, the whole set of generations of the human being is one person, which goes back to the idea that, I mean, obviously we're not one person. I'm not suggesting that.
Trying to figure out where you were going with that.
Each person, but from a physical standpoint and the way God designed it, we are all descendants of Adam.
Yes.
Okay, so.
And we can prove that.
Yeah, and so in that sense, it's kind of like one
lineage, at least.
Yeah, or one sort of organism that's kind
Not
of
exactly.
Well, anyway, that's my question. Is what that's leading up to is the question that people have talked about. The whole body type is that the cell isn't completely dependent on the DNA so much as it's dependent upon the context in which that DNA has resided when it was in the egg, when it was in the womb, and all that sort of thing. And that has an awful lot to do with, how the person is going to be shaped. So this is the question, but before you start answering that, I just want to make my comment. In regard to this whole question about these cells communicating with one another and how they know to make the bone end of the bone smooth or make a jaw out of leg bones or whatever it was you're talking about. A long time ago I had a sort of an interesting little revelation, you might say, is that I was contemplating the way a bat, which cannot see, can still navigate with just as much accuracy as some animal that can see. In fact, possibly even better accuracy. And I realized that probably what's happening, of course, this is just pure conjecture, but probably what's happening is that bat sends out its signal. The signal bounces back, and his brain is designed in such a way that he can actually see in his brain. It's just a different kind of sight. Mm-hmm. It's almost as though his eyes are based on the sound frequencies that he's using, and the way his brain is designed to process the radar information. Mm-hmm. Well, I think there's a little bit of analogy between that and the way these cells operate, because every cell has the same set of DNA, the same genome, and that genome does set perhaps something about the way the body is, that particular person's body is supposed to be shaped. And considering the amount of information that's available in that genome, it sets that information, knows that information to an extremely detailed level. Mm-hmm. And so what I'm suggesting and conjecturing is that once a cell senses the context that it's in, it can, in a sense, in the same way the bat can interpret the sound signals into an image, the cell can sort of, in itself, through its chemical processes, and possibly by the Spirit of God or the spirit of the being that it's in, it can form its own sort of inner image of where it's supposed to be. And then based on that, it generates the right chemicals and whatever that moves around to adjust its context back to where it sees that it's supposed to be. So that's my comment, but I'd appreciate it if you could answer that previous question.
Nice. I think you're getting into the realm of epigenetics. And epigenetics is almost, but not quite, Lamarckism, where we inherit acquired traits. Well,
I'm not advocating it.
No. Apparently, there is some truth in that in the realm of epigenetics. And the epigenetics controls how our genome is affected by the context and the general environment. So the entire being, the entire entity, is affected by its environment through nourishment, through environmental factors, heat, cold, oxygen content, things like that. But there seems to be actually a change or a change in expression of genes depending on that context, in the macro and in the micro. So yes, that was also part of what I got from Dr. Leitner. Apparently, there's something going on at the gene or genome level that's affected by environment as well. But she threw me for a loop because I'm pretty sure I heard her say that the genome selection seems to know what that organism is going to need. Now, how is that affected by the environment or context? And yes, the development of the embryo, there's something about the development of these cells, their position, their context, that seems to know what they're going to do. How do it know? I don't know.
Can I make a comment?
But yes, yeah.
Of course, this is all by analogy. I don't study this stuff, but in signal analysis, there's a process known as, I'm not going to use a term, okay? There's a process that you can do, which it's a relatively simple process. You can write a computer program to do it, and the computer program appears fairly simple, but when you put it up against a signal, it comes up with what's called a filter, which is an extremely complicated filter. But this filter is also extremely adept at predicting regular patterns within the signal that you've been analyzing. They use it in seismic work all the time. And it's
used in radio signals, all kinds of things.
Extremely powerful technique. And what I'm kind of leading up to is that if you take a simple algorithm like that, which can make such a complicated prediction, and it isn't a predictive thing where it just repeats some pattern.
Right.
It's at a much deeper level than that. It repeats the frequency spectrum in a way that you just can't do by observation.
Right.
But at any rate, what if you take an incredibly complicated algorithm like goes on in the cell, and it observes all these patterns, then it seems to me quite reasonable that it could predict in a temporally and spatially what this organism is going to need in the future. So I'm just All right.
Actually, probably. That's a very good observation, and one of the better explanations on how does it know what to do next. You know, and yes, it is context, it is spatial orientation, but there seems to be some communication from different parts. So yes, there is some information analysis going on there that gets it from point A to point B with several other inputs going on at the same time. And obviously, at the same time, filtering out disinformation. You know, and this algorithm would be doing that too. You know, things that are so outside the parameters, it knows that it's noise. So, yeah.
I learned everything about babies from a white male from European descent named Bill Nye. So could you explain...
Oh dear, I'm so sorry.
Could you explain to me this thing about the rib and Eve? How does that play into it?
I wasn't there, and I don't have the exact genetic map, but no, males don't have one fewer rib than females. Ribs are one of those bones that can and does totally regrow. So when God closed the wound, if it was indeed a rib, I believe it said from his side, but sure, rib works because it's genetically complete, but God had to replicate the X chromosome to make that entity female. Real tough for him. So yes, the woman was completely genetically related to the male with replicated X chromosome. We can, this is sidestepping your question a little bit, we can look at the genetic information that's not found in the nucleus. There's genetic information outside the nucleus that's provided strictly by the mother. Hello, egg, mom. Okay, so we can look at this somatic DNA and prove that every living human being had a common female ancestor. We can do the same thing with the Y chromosome, which is incredibly conservative. I'm not sure where that's going. And we can look at the Y chromosome and prove that every male on the planet had a common male ancestor. This is pretty much irrefutable. So, just looking at the genetics alone, we know we had a male and a female common ancestor. And we weren't there and can't prove the genetics, but yes, Eve was totally genetically related to Adam. Flesh of my flesh, bone of my bone, yes. So, not too hard for God.
This is kind of a simple question, but maybe profound. I don't know how this all relates to this, but are we dust?
Actually, that is profound. And doing a chemical analysis of the body, which we did back in physiology days, yes, we're dust. We're common minerals, metals, proteins made of very common atoms. So yes, just to boil it down, we're wet dust, which makes us mud, and we walk around in a bag. So your earth suit is a mud bag, which will return to the dust. It's a pretty simple but profound answer. Yes, sir.
I have an observation and a comment that I'd like you to respond to. My observation relative to Dr. Leitner's impression that somehow our genes can know what we need ahead of time.
I liked his analogy. That shines some light on this topic.
My observation is one that I wonder if other people have had.
I'm pretty ignorant when it comes to computers, and my little 3-year-old just loves them, and my 5-year-old, and they pick it up like it's just candy. And that's my observation. This stuff that I have trouble with, they just, oh, and it's so that's my observation. The other comment is about the scripture relative to much of what you've discussed. And it says, in him we live and move and have our being.
Have our being, yes.
So just,
and boy, if that doesn't sum up what we've talked about here, I don't know what does. That pretty much, nailed it. And I'm not sure we need any more questions after that. I love that exclamation point.